Hello and welcome to another one of Dee's ADD videos. Today we're going to be looking at elimination reactions, specifically the unimolecular elimination reactions, otherwise known in short as E1 reactions. When there's a moderate or weak attacker like an alcohol, water, things like that, then the reaction is going to be a one reaction, unimolecular, solvolysis. All those terms are synonymous. Solvolysis and the fact that the alcohol will do all the attacking. All right, so first step is usually to form a carbocation. After that, a substitution or elimination can occur. If you add a little silver nitrate, you can push it this way. A little tricky depending on the conditions. A little heat can usually drive it toward elimination. So we're going to focus specifically on the elimination part of it. Again, all one reactions are two steps. In the E1 reaction, the first step was to form the carbocation, just like in the substitution SN1 reaction. But now the solvent's no longer acting as a nucleophile. It's going to act as a base. So the solvent's going to attack a hydrogen that's on an adjacent carbon to the electrophilic carbon. All right, so hydrogen next to it. Next to the carbocation. What happens then is we end up forming a heterolytic cleavage in which one of them gets all the electrons and creates an anion, and then the other one gets none of the electrons in the covalent bond and forms a cation. All right? So this is an alkyl halide, leaving group left, formed your carbocation. Again, we like polar protic solvents because they aid in solubility, and they're also going to aid in stabilizing the ion. After we formed the carbocation, we could have done a nucleophilic attack, but here, again, if you remember, we're going to attack an adjacent hydrogen and form an alkene. So here we formed our carbocation and our leaving group, and basically what's going to happen is we're going to have rearrangements occur at this stage if we can increase the stability of our carbocation. If you remember, resonance is the most reactive and most stable, and then it's going to go tertiary, secondary, primary, methyl. All right? The polar protic solution is going to stabilize these ions, aid in their solubility. So the next thing we got to do is look at what happens is we form an alkene. All right. What happens is the lone pairs of this oxygen come abstract one of these adjacent hydrogens. Doesn't matter which one. In this case, there's no asymmetry. So when we take the hydrogen away, we get a protonated alcohol, and we leave the electrons behind from this covalent bond to fill this empty p orbital and form a pi bond. Once we form the pi bond, we have our alkene. Again, if you remember the solvent criteria, all our alcohols are great. They need to be polar to stabilize the ionic intermediates that you get here. Also, it aids in the solvation of these ions to stabilize them. So if I have a alcohol and the hydrogen is partially positive, it'll surround this leaving group once it leaves because it's negative. Make it harder for it to come back and do any damage. Again, stable leaving group helps ensure formation of a carbocation. Good leaving groups are halogens, tosylates, and mesylates, a bunch of oxygens and bonds. You can look up their structures if you want to. You do see elimination and substitution and rearranged products, so it's bad for synthesis reactions typically. Although you see both elimination and substitution products and even rearranged products in one reactions, remember that's the reason they're not good synthesis reactions. It is possible to guide them to favor either substitution or elimination. I mentioned at the beginning of the video, you can heat the reaction, and it's a little tricky, but it'll tend to favor elimination. You can add silver nitrate, AgNO3, and it'll push it towards substitution. Okay. Conditions are a little tricky, but typically if you see those two things, that's what you'll see. Some exceptions are bound to occur. All right, so that's typically what you need to know for E1 reactions. Remember, weak, moderate alcohols, waters, things like that. It's a heterolytic cleavage. We form the carbocation, resonance 3-2-1, reactivity and stability. Here we're going to have leaving group leave, create the ions. The polar protic solvent helps solvate and stabilize the leaving group. Also, the polar part of it helps in the solubility of these ions. Then the alcohol solvent, again, solvolysis reaction, solvent does all the work, is going to come and remove one of these adjacent hydrogens and give you an alkene plus a protonated alcohol. We will be discussing Zatsiev's rule in the example videos, but if you have an asymmetric carbocation and you have multiple possible products, the more of these hydrogens we replace, the more substituted it is, the more likely it'll be your major product. All right? So again, the more substituted, the more stable, or the higher the yield of that more substituted possible product. All right? Again, always has to be adjacent to the carbocation. Acting like a base, not a nucleophile. Check out the example videos, it'll make more sense. More importantly, practice, practice, practice as much as you can. This is the beginning of a bunch of different types of reactions. Though their central themes might be the same, and you can see a big picture, their details will differ. And unless you do a bunch of these, you will be lost when you see a new problem. All right? I hope I've clarified things enough for you to try. As always, thanks for watching and have a great day.